Okay, so calculating probabilities by conditioning. How do we use this conditional probability expression to calculate the probabilities? Actually, what I'm trying to do here in this part of this section, we are going to twist this conditional probability formulation, and this time we are not going to calculate the conditional probability, but we are going to calculate the probability of the intersection of events if we are given the other two information. So according to this formulation, you can easily say that the probability of E intersection F is equal to probability of F times probability of E given F. So let's just assume that F is the event that occurs the first over the timeline. So when we observe these events, we first observe if F is not occurred or not. Then after F has occurred, we observe if E has occurred or not. So the probability of these two events to happen altogether is the probability of the first event times probability of the second event given that the first event occurs. Okay? So we basically calculate the probability of the first event and we chain it by the probability of the second event. However, we assume that the first event has already occurred. Now, you should not stuck yourselves to the direction of the timeline. I mean, because intersection is a symmetric operation, you can write this equation by first calculating the probability of the event E, then the probability of F given event E. So the probability of the second event times the probability of the first event given that the second event already occurs. So you can also think in the reverse of the timeline. So this is intersection. Intersection is a symmetric operation. You can start by writing the first event, whatever you would like. So you write the probability of the first event, then the probability of the second event given that the first event occurs. So you can choose which order you would like. It doesn't matter. In both cases, you would get the probability of E intersection F. All right, so we are going to solve a question related to that. Selin is undecided as to whether to take a French course or a chemistry course. Okay, so we have two courses. One of these two courses is going to be selected by Selin. She estimates that her probability of receiving an AA grade would be 1/2 in a French course and 2/3 in a chemistry course. She is much pretty well in the chemistry course, so she assumes that if she selects the chemistry course, the probability that she is going to get an AA grade from that course is 2/3. But if she selects a French course, then she assumes that her chances are less. Then the probability that she gets an AA from this elective course would be 1/2. Now she is going to select one of these courses. And because she is undecided, she is going to decide to base her decision on the flip of a fair coin. She is going to flip a fair coin, and if the coin shows a head, she is going to select French, let's just say, and if it's a tail, then she's going to select the chemistry course. So there is a 50-50 chance for Selin to select any of these courses. The question is asking us this. What is the probability that she gets an AA in chemistry? Or in other words, what is the probability that in her transcript there will be chemistry with an AA next to it? So we are going to describe this situation. Let A denote the event of her to get an AA in this elective course that she has selected. She can either select the chemistry or French. It doesn't matter. A is the event of getting an AA in the selected course. And C is the event of taking chemistry. And we know that the probability that she is going to take chemistry is the same as the probability that she is going to take the French course, because she is going to base her decision on the flip of a fair coin. That is going to be 1/2. And if she selects the chemistry course, if event C occurs, the probability that she assumes for getting A is 2/3. So she assumes that the probability of getting AA if she selects chemistry is 2/3. Now the question is asking us this. What is the probability of getting an AA from chemistry? Now for Selin to get an AA in chemistry, first she needs to select the chemistry, And after selecting chemistry, she needs to get an AA from that. So we are basically calculating this probability in the regular direction of time. The first event is selecting the chemistry, which has probability of 1/2, and the second event for her to take an AA given that she selects the chemistry, which has 2/3 probability. So A intersection C has this probability. Probability of C times probability of A given C, which is 1/2 times 2/3, which is going to be 1/3. Let's move forward. Let's solve another question. It says, suppose that an urn contains 8 red balls and 4 blue balls. So urn contains 8 red balls and 4 blue balls, and we draw 2 balls from the urn without replacement. So do not forget about this statement. It says without replacement, which means, so there are 12 balls here. I am randomly drawing a ball and putting it aside. I do not replace it. It says without replacement. And then I randomly draw another ball from the remaining 11 balls. This procedure and selecting both balls at the same time is the same. Okay, this procedure and selecting both balls at the same time is the same. If we assume that at each draw, each ball in the urn is equally likely to be chosen. So whenever you select a random ball, whenever you perform a random draw, each ball is equally likely to be chosen. Part A, what is the probability that both balls drawn are red? Part B, what is the probability that both balls drawn are blue? And part C asks, what is the probability that the balls are of different colors? Actually, we can answer this question using the knowledge that we have learned in the last 2 hours, last week. So we can use the combinatorial analysis knowledge, and we can determine the number of elements in the sample space. You know, if there are 12 balls, we can say that there are 12 choose 2 possible outcomes in the sample space of this experiment. And for part A, we can write in the numerator 8 choose 2 times 4 choose 0. For part B, we can write 8 choose 0 times 4 choose 2. And for part C, we can write 8 choose 1 times 4 choose 1. Okay, so this is the approach that we have known so far. However, starting from today, we can also solve this kind of question based on conditional probabilities. So this is what we are going to do. We say that R1 and R2 are denoting the events that the first and the second balls drawn to be red. So R1 is the event that the first ball drawn is red, and R2 is the event that the second ball drawn is red. Now, probability of R1 is 8/12 because there are 12 balls, and in the beginning there are 12 balls and 8 of them are red. Therefore, in the first selection process, the probability of selecting a red ball is 8/12 or 2/3. And the probability of selecting a blue ball can be represented as the complement events probability. And my friends, please realize that we should not consume all possible letters when denoting the events. If R1 denotes the event of selecting a red ball in the first try, then R1 complement represents the selection of a blue ball in the first try. So we should not use another letter. For example, blue starts with B, so we should use B1. Do not do that. It's not necessary. Okay? So selecting a blue ball is the complement of selecting a red ball. So the probability of selecting a blue ball in the first try is 4/12, and that is 1/3. Now this is still the information given by the question. Now in part A, the question is asking me this intersection probability. What is the probability that both balls selected are red? Which means the probability of R1 intersection R2. The first ball is going to be red. The second ball is also going to be red. We know the probability that the first ball is to be red is 2/3. And given that the first ball is red, there remains 11 balls in the urn, and 7 of them are going to be remaining as red, right? So if the first ball selected is red, 11 balls will be remaining in the urn, and 7 of them are going to be red. So you can write this probability as well. Given that the first ball is red, the probability that your second selection would be red as well is 7/11. Therefore, this intersection probability, R1 intersection R2, is the probability of the first event that occurs over the timeline, and given that the first event occurs, the probability of the second event to occur. So this is 2 over 3 times 7 over 11, which is 14 over 33. This is the probability of selecting 2 red balls. You can, in fact, calculate the same probability as in we used combinatorial analysis knowledge. You can use number of combination formulations to determine the number of elements in the desired event and in the sample space, and take the ratio of these 2 values. Now for part B, the question is asking the probability of selecting blue balls in 2 selections, which is the probability of selecting a blue ball in the first try and the blue ball in the second try, which is denoted by R1 complement intersection R2 complement. In the first try, we know that we can select a blue ball with 1 over 3 probability, and given that the first ball is selected is blue, the probability that the second ball selected is also blue will be 3 over 11, because there will be 11 remaining balls in the urn and 3 remaining blue balls in the urn. So again, the probability of this intersection event can be represented as the probability of the first event that occurs over the timeline, and given that the first event occurs, the probability of the second event, which is 1 over 3 times 3 over 11, that is 1 over 11. Now, for part C, it says, what is the probability that the balls are of different colors? Now, if you know the probability of part A and the probability of part B, you can easily compute the probability in part C by subtracting the first 2 probabilities that you have calculated from 1. That's the easiest approach to do that. So we can answer this part. However, we can also use the mathematical expressions just like before. And we can say that the question is asking me this probability statement. The probability of the first ball to be blue and the second ball to be red, and the probability of the first ball to be red and the second ball to be blue. In both of these 2 disjoint cases, now please notice that this event and this event, these 2 intersection events, are disjoint from each other. They are mutually exclusive. Therefore, when we sum up the probabilities of these 2 disjoint events, we get the probability of selecting different colored balls in the selection process. So let's calculate the first probability. The probability of the first ball to be red and the second ball to be blue. I'm sorry, this is the second component in the summation. So we start from the second. The probability of the first ball to be red and the second ball to be blue, which can be expanded as the probability of the first ball to be red times, given that the first ball is red, the probability of the second ball to be blue. We know the probability of selecting the first ball as red as 8 over 12 times, once you select a red ball, there remains 11 balls and 4 of them are still blue, because in the second part we are talking about a blue ball. Therefore, this probability will be 4 over 11, which is 8 over 33. In a similar manner, my friends, you can calculate the probability of selecting a blue ball in the first try and a red ball in the second try, which would be 4 over 12 for the first ball to be blue and 8 over 11 for the second ball to be red, which is again 8 over 33. When you sum up these 2 probabilities, you get 16 over 33 as a result of this question. In fact, these 3 probabilities, if you check 14 over 33, 3 over 33, and 16 over 33, they sum up to 1. So these 3 events are all possible events that can happen. And all these 3 events, the first event, which is both balls to be red, and the second event, both balls to be blue, and the third event, both balls to have different colors, they are disjoint events. These 3 events are mutually exclusive from each other. However, their union covers the whole sample space.